everyone, welcome back to my YouTube channel Z2H classes. In this video, again we will solve few MCQs for BARC written examination. So in first MCQ, we are given a matrix and asked that which of the following equation will satisfy this matrix. So in previous video also I have discussed Cayley-Hamilton theorem. Sometimes it is written as Cayley-Hamilton theorem, according to which a matrix must follow the equation given as characteristic equation of Cayley-Hamilton, that is determinant of A minus lambda I must equal to 0. Since this is 2 cross 2 matrix, so our I will be 1 0 0 1. So I write it here. Our A matrix is 1 2 5 1 minus lambda, and I for 2 cross 2 matrix is 1 0 0 1 is equals to 0. So it will take the form like this: 1 minus lambda, 5 2 and 1 minus lambda is equals to 0. So it will be 1 minus lambda square minus 10 is equals to 0. So now using expansion we will get 1 minus 2 lambda plus lambda square minus 10 is equals to 0. So it will be lambda square minus 2 lambda minus 9 is equals to 0. And now substitute A instead of lambda, we will get A square minus 2A minus 9 is equals to 0. So this equation must followed by this determinant, or you can say matrix. So correct option will be A. Now move to the next question. In second question, we are this is from statistical mechanics. We are asked that if two systems A and B have microstat P and Q, and entropy is M and N, then we are asked total microstat and total entropy. So total microstat is always multiplication. So total microstat omega is always omega 1 into omega 2 and here omega 1 and omega 2 we are given entropy microstat as P and Q, so it will be P into Q. So total microstat will be PQ. And total entropy always added, because entropy always increases. So that total entropy will be always added, and entropy here we are given as M and N, so total entropy will be M plus N. So here correct option will be PQ and M plus N. PQ and M plus N. So correct option is PQ M plus N. Correct option is B. So correct option will be B. So our correct option is B. Now third question. This is from solid state physics, in which we are given that plane intersect a crystallographic axis at A, 2B and C, then what is the Miller indices? So in order to find Miller indices, we have to follow few steps, and first step is to take reciprocal. First step is to take reciprocal. So now take reciprocal of A. So here factor is 1A, so it will be A upon 1A. Then take reciprocal of B. Here factor is 2, so it will be B upon 2B. And C has factor 1, coefficient 1, sorry, so it will be C upon 1C. So reciprocal will be 1 upon 1, 1 upon 2 and 1 upon 1. Now second step is to take LCM, or you can say multiply this reciprocal by 2. So in second step I simply take LCM, so I multiply it by 2, so it will be 2 divided by 2 and 2, so it will be 2 1 2. So Miller indices for this plane will be 2 1 2 2 1 2. So correct option is C. Correct option is C, 2 1 2. Now fourth question, in which we are asked that total internal energy of diatomic molecule at high temperature, so it will be 7 by 2 kT or 7 by 2 kBT, where kB is Boltzmann constant. It is from equipartition theorem, which states that degrees of freedom, you can remember this, you have to remember it directly, but I explained how it comes. So degrees of freedom for diatomic molecule, degrees of freedom for diatomic molecule is 3 at low temperature. And these 3 degrees of freedom just contain translation motion. So these 3 degrees of freedom contain only translation motion. Translation means linear motion. Translation motion, or you can say linear motion. And there will be only 3 degrees of freedom in x direction, y direction and z direction. But it is at low temperature. When you come to the room temperature, there is degrees of freedom also contain due to vibration energy. So your degrees of freedom will be 3 for linear and 2 for rotation. So total degrees of freedom will be 5 at room temperature. Okay, so this 3 is due to translation motion and this 2 is due to rotation motion, and your degrees of freedom is 7 at high temperature, because at high temperature vibration motion is also present. So at high temperature 3 due to translation motion, 2 due to rotational motion and another 2 due to vibration motion. So this 3 is due to translation motion, this 2 is due to rotation motion and this 2 is due to vibrational motion. So total degrees of freedom at a high temperature is 7, and internal energy is given as F by 2 kBT, and in question we are given at a high temperature. So at high temperature F is 7, so it will be 7 by 2 kBT. So internal energy of diatomic molecule at high temperature is 7 by 2 kBT. So correct option is D. Now last question for this video is state that for a conductor of radius R, the magnetic field B inside the conductor depend on R as. So inside the conductor it depends as proportional to R. Okay, you may remember this graph from class 12, magnetic field versus distance R. So suppose your radius is A, so at R is equals to A, your magnetic field is maximum, and at R less than A, this portion R less than A, your magnetic field is proportional to distance. and this side your magnetic field is proportional to 1 upon R, where R is greater than A. So your correct option is A. Thank you for watching my video.